Good morning everyone. I am Japan Gaur. Today at TouchCore Education we are going to learn about solar thermal technologies. As we are aware, solar energy technologies are classified into two categories. One is solar PV technologies, which are mainly dealing with light, and second is solar thermal technologies, which mainly deals with heat from sun. So we are today going to look at solar thermal technologies which deal with heat of sun. Solar thermal technologies have not been new to humankind. We have been using that knowingly or unknowingly, mainly in our home appliances or even some envelopes of homes, residences, houses, offices. Solar thermal technology, first it's said that being used in Greece. Greek people had used it to make appropriate houses for them. As this technology have been used for them for ages in terms of passive solar energy. If I classify solar thermal technology into two different categories, one is solar passive energy and another one is solar active energy uses. Solar passive energy uses do not require any direct or indirect equipments, while solar active energies require some sort of equipment arrangement. In solar passive energy, what we see in most of the houses that some openings are available in terms of windows, shades, doors, etc. Those provide sunlight as well as heat from sun to enter in the house envelope, and they warm up the space. So that is the solar passive use of solar thermal energy. As you can see in the slide here, there have been some constructions shown here in ancient designs that this cliff provide some sort of a protection as a shade in winter, in summertime when sun is on the top. Movement of sun, or rather movement of earth, rotates and revolves around sun in such a way that when we see from earth, we feel sun is passing through earth in winter at a lower altitude, rather in summer at a higher altitude. So what we see here in a diagram or in a figure, that these cliffs provide some sort of a shade or a protection to the houses right below it in summer. So direct sun or maximum heat cannot be penetrated through these windows and openings what we see here, and by that the temperature is maintained. In winter, when sun passes through lower altitude, this cliff do not hinder sunlight and heat to penetrate in these houses, rather they help to warm up the rooms which are directly having these windows in south facing in northern hemisphere and in north facing in southern hemisphere. And this is one of the best example of passive energy use. Next one what we see is different modern designs in the houses. For example, apertures, which are the windows which we have already talked about. Then absorbing materials, which are generally dark material which absorb heat. However, these are more required in colder countries or colder regions where we need to store heat in certain materials which can be used throughout the day. In tropical regions, we have enough sunlight and heat, so these might not be required in tropical regions actually. Next is these heat storage materials or heat storage devices, which are generally bricks, concrete materials which are used in building material. Then distribution system, like ventilation, reflective surfaces. Thus, ventilation can be natural draught or they can be forced draught as well. And the last is controlled mechanism like sunset, opening windows, shutters, etc. They basically alter the amount of sunlight and heat required to penetrate in the house. So what we see here is mostly about use of passive energy in the houses.